Okay, we're in section 23 of the notes. And again, the hope is that you spent some time thinking about what we presented to you, including the examples we presented to you, and starting to think about doing more than that, which means doing the embedded problems in the notes and the WebAssign. All right, what's this about though? It's using Sage. So reset, and again, it's something that I'm hoping you're getting used to me doing this for you. And of course you might say, well, I can do it myself. Well, that's our goal here. Our goal is to get you guys to do what's right, all right, which is working on your own, right? You really want to work on your own. You want to be constantly told what to do. It's a very uncomfortable situation if you're employed and they constantly are telling you what to do, all right? It's nice to have some freedom over here. And so I'm going to, I don't know, I guess I'm going to do copy paste now. I think I can read this stuff, right? One second. That's f of x. It's a cubic polynomial. Where did you study the cubic polynomials? Well, it goes back in algebra. Certainly, you refined your techniques in Math 119 for the cubics. All right. And I'm going to type in df, this over here. What does it do? It assigns df as a function, and that function is defined to be the derivative of f with respect to x. So that's done. Let's talk about this line of code over here. It's solving the equation where the derivative equals 0. And so it assigns it to S. What is assigned to S? The solution. Let me just type S in for you and show you. That might look strange to you. So this looks like we could probably have done that by hand. Yeah. So if we took the derivative and solved for 0, well, the derivative of that cubic would be a quadratic, and quadratics are fairly easy to solve. Right? It says the solution to that quadratic, when that quadratic equals 0, the roots of it would be 3 and 1. All right. So next up, and I want to just type in some things over here, what they're doing, like f of -1 evaluates the function at -1. Right? I could play around with this. I could do df at 3. What should that be? That should be 0, right? Okay. I should do df of 1. What should that be? That should also be 0. And why is it? We have Sage to solve it. Okay. Let's keep moving. And again, you could type all that stuff in as well. All right. Pretty simple stuff. You could also plot f of x. Let me do that for you. And again, just rely upon your past now. And someone said, why would I do that? I want to see what f looks like. And I want to see what happens at 3 and 1. All right. Well, I don't like the picture. So I'm going to change it. Right. What am I going to change it to? Well, I'm going to change it. I want the x min now to be, let's see, I want it to be, I don't know. Let's do -1. And let's do the x max. Again, this may not be good either. But I'm going to do 4. And why is that? That includes the numbers 1 and 3. Let's see what happens. I'm getting a better picture now. All right. So I want to discuss the picture with you with respect to the Sage code. Right. And we're learning. That's why we're doing this. At least I hope you're learning. If this is something where you're looking at, say, I have no idea what I'm looking at, you're probably not putting enough time into this. What am I saying? At x equals 1, something occurred. And what occurred over there? Well, that's where the derivative would be equal to 0. And we're getting a relative maximum there. What happened at 3? Well, that's where the derivative became 0. And we're getting a relative minimum there, right? The function's increasing here. It's a relative maximum. It decreases. It's a relative minimum. And then it increases. Okay. That's good. Good to know that. Let's do the next line of code. All right, let's do this over here. Let's see what this gives us. More difficult. And we'll just talk through it. I'm going to clear the screen first. I want to remind you, clear has no effect on the variables in the problem. And then I'm going to do, I don't know, dg. What do you think dg stands for? The derivative of g with respect to x. And yep, I'm copy pasting. Got dg. All right, this is a weird one. It says Boolean, does g of 3 equal g of 9? Well, let me type down g of 3 first. That equals 1. Let's type down G of 9. And this has something to do with the problems that you're working on. And this is why it's so important to study. When you study, you'll see the relationship between this and the past. Now, what do I know? I know G of 3, G of 9 are both the same number. Well, that's what that Boolean does. Let's do that. Bool. We're asking the question, is G of 3, is it the same thing as G of 9? And what's the answer to that? Of course it's true. We just did that. Okay. Now what I want to do is I want to do this and we'll discuss it. Let me display S for you. And it says S is 9/2 and 0. All right, let's talk about where this is coming from. It looks like they're talking about, Raoult's theorem. So I'm going to say the function, I'm looking at it, x squared over 12x minus 27 is continuous on the interval between 3 and 9. And that seems to make sense to me because I'm looking at that and it would have some problems where it's not in the domain of the problem, where x is going to be 27/12. So that 3 is above that number. And between 3 and 9, there's definitely, if I did a pencil without drawing it, that my pencil would never lift off the page. I want to plot that for you. I'm going to plot G of X now. And again, I don't like the picture. I'm going to close it. I'm going to try again. So I'm going to plot this between X min, between 3 and X max to be 9. All right. So what am I seeing over there? I'm seeing the picture. Let me go back to my code. I'm seeing a picture of G between 3 and 9. So this is 3 over here. It evaluates the number 1. Well, we've already discussed that. And this is 9 over here. And that's going to evaluate to 1 as well. So what I know there's a line that goes through there, and that line would have slope 0. So the continuous function, it's differentiable on the interval. I'm expecting to get a value over here, which would have a horizontal tangent as well. All right. That's what I'm expecting. Now, what does it say? Over here, I solved the derivative for 0, and it says I'm going to get a horizontal tangent at 9/2. Well, what's 9/2? 4.5. But it also says 1 would occur at 0, but that's not in this interval, by the way. So 9/2 is over here. What's 9/2? That's 4.5. And what's 4.5? I'm going to say somewhere about here. There's a horizontal tangent here. Now, someone says, could you read that from the graph? I don't think so. I really don't. Even if you were to take this graph and start to blow it up, right? 4.5 is over here. I don't know if I'd be able to mark that as being the exact location because I'm looking at this thing. It looks flat in a region. I'm just not sure exactly where it becomes perfectly flat or horizontal. All right. But around 4.5. All right. It told me that over there. Let's go back to our code. And I want to just talk about the last line of code over here. And let's discuss that with you. So it takes S. I want to tell you what S is. It's up here. S, it's a matrix, by the way. When I say it's a listing of two things, first thing, second thing, remember, Sage starts counting at 0. So what's S0 stand for? S0 stands for the first entry. And this is the first entry, but I don't want the first entry. What I want is the first entry's right-hand side. So what I do over there, right-hand side. Now, what's DG at this number? I'm evaluating DG at the number 9/2. And what's that going to be? It should be 0. And it's 0 as we expected. All right. Now, let me just try another one. I'm going to do S1 right-hand side. What should that be? That should also be 0. Okay. All right, let me get a better picture. By that, I'm going to go back over my thing, and I'm going to do from minus 10 to 10. Again, you need to start playing with software. All right, that's a bad picture. What happened? I went from minus 10 to 10, but I'm now noticing the Y scale is just outrageously large. So I got to change that now. Let's see if we can do that. I'm going to change the Y scale now. Y min. I'm just playing. I'm going to say, I don't know, minus 10 to 10. And this may not be good either. I'm just playing around with software. I'm going to try and encourage you to do that as well. Well, that's a better picture. I'm seeing that I got a poll there. Let me see if I can do that. And I think you might remember. I think I might have done that. And detect. Oh, I kind of remember that. You know, when I say I remember things, not always. And I got a problem over here. What's the problem? Is an error. What's the error? It says non-keyword argument after keyword argument. All right. So what I want to do is you say, I can't remember that. What you do in the notes, search, find, detect. And I see it now. You see that? Let me go back to my graph, and I'm going to type in that code again. And this is something you want to learn to do, to search a document for things that you might have seen in the past. So detect polls equal show. Granted, I may type it in wrong again. Let's see what happens. I'm getting a much better picture now. What picture am I getting? I'm getting that vertical asymptote, something you studied in Math 119. So again, you start building on a skill set. Does the skill set grow over time? Only if you try. If you don't try, your skill set is not going to grow. It's actually going to shrink. All right. And that's not what we're looking forward to. We're looking forward to changing your opportunities. And we want those opportunities to be good opportunities. And that is being well educated and having options when you get out of school. Thank you.